For this question, we have a certain radioactive gas in a sealed chamber, and we have the ln A against T graph. Okay, so a quick recap, right? How to get the shape? How do we know the shape of the graph? For only one gas, right, we should expect a straight line graph because, right, A equals to A naught e to the power minus lambda t. When you ln both sides, you can get a linearized graph when you plot ln A against time. However, right, when you have two different samples together inside the same chamber, right, then when you try to ln the activity, because it's comprised of the contribution from both gases, so it's no longer gives you a linearized graph. Okay, so you should expect, right, a curve for the second part. However, right, how do we know what is the shape of the curve? We wouldn't be able to like predict mathematically. Instead, right, we can do in a qualitative way. Okay, so in this chamber, right, two gases are giving rise to the same activity. Okay, one of them, right, is a lot more aggressive, a lot more zealous, which is the second gas. How do you know that? Because it have a much shorter half-life. Okay, that means, right, it has a much larger lambda. Okay, therefore, right, the activity is larger, and if the activity is larger, right, that means that it will decay and die out faster. So we should expect, right after you inject the new gas, the shape of the graph, right, will be dominated more by the second gas, and the second gas, right, has a higher activity, larger lambda. So imagine, right, if there's a second gas, the second gas alone will have a steeper gradient. So it's like a steeper gradient here, contributed by the second gas. But this second gas die out very fast. So eventually, right, after a long enough time, most of the second gas will have decayed. So what's left over inside the chamber is the first gas. And the first gas, right, what will be the decay constant? It will be the original graph, original shape. So after a long time later, right, so you'll be dominated by the first gas shape. Yeah. Therefore, right, the curve for this second part will be like this, up, dominated by the second gas shape, then eventually, right, smoothen out back to the original gradient. Also, right, you may ask, why can't it be option C? Because, right, option C also follows back the same gradient. However, right, you see, when the second gas have died out, right, after most of it has decayed, what should remain, right, is the first gas. Therefore, right, the activity should drop back to the original level of the first gas, so which goes along this line. Therefore, the graph, right, must goes back towards this line. Yeah, which is why C cannot. So answer is D.